So in continuation of our the earlier lecture, we would like to see a few more examples based on Norrish type 1 reaction and see what is the probable product form in alicyclic ketones and so on and so forth. So next example is this one. If we have a system like this, then let us see what this is a bicyclic ketone, and then in the presence of light, looking for the most probable photoproduct in this ketone, H nu. This is comes under alicyclic ketone. We know that the alicyclic ketone in the presence of light undergo type 1 reaction. Type 1 reaction which involves alpha bond cleavage, and alpha bond cleavage. And if the alpha carbon is substituted, then it has to undergo preferential. So these are the two alpha carbons, alpha and alpha dash. If we cleave this alpha bond, we are going to end up with a tertiary carbon center radical. If we cleave this alpha bond, is going to give us a primary, there are two hydrogens here, so it is going to give a primary carbon central here. So hence it undergoes a preferential bond cleavage, alpha bond cleavage, to give a more stable carbon center radical. This one, and then this is the first step, and the involvement of these radicals have been well established by trapping agents, as we have seen in the last lecture, that both the carbon center radical as well as acyl center radicals have been trapped by the free radical quenchers such as tetramethyl piperidine N oxide to give the corresponding radical. So this may also undergo is a tertiary radical, and this is a more stable radical as compared to the other cleavage. So this will undergo a preferential alpha bond cleavage to give a carbon center radical and a acyl radical. This is open for now the different pathways to drive the product. This will undergo minus CO to give a radical like this, and then this will combine to give a carbocyclic system. This is one of the product which is possible in this particular case. The other possibility is the abstraction of an hydrogen atom from the the adjacent methyl group. So this will abstract this, and then this will form a double bond. So the second possible product could be an aldehyde, right, and slightly bigger. So this is an aldehyde, and then this will two methyl groups, and then this is the other possible product. It is also possible that this radical may abstract an hydrogen atom from here, that to give there is a third ketene to give, and then corresponding the H here. So this will So this is a methyl group. So this is an abstraction of hydrogen atom. This is a ketene. This is another possible fragmentation of this intermediate to give this ketene, and then this will give, in the presence of solvent, given alcoholic solvent such as ROH, give an ester, and if it is an some moisture is there, it will give an corresponding acid, and this will convert to an ester and acid. So the corresponding ester will be the corresponding in the presence of solvent, like ROH will give a product like this. So we'll just write in a slightly better way, this one, and then C double bond O, and then OR. So this is a corresponding ester, and corresponding acid will be C double bond O, OH. This is the corresponding acid. So these are few possible products which is formed in this particular decarbonylation, and then corresponding aldehyde, and the decarbonylation followed by coupling, and aldehyde, enaldehyde, and so on and so forth. And then now let us see another example where when we have a system like this. This is a dimethyl substitute. Both the alpha carbon, this is alpha carbon, this is also alpha carbon. Both carbons are dimethyl substituted, and hence in the presence of light, this will undergo type 1 reaction. One reaction which involves alpha bond cleavage, and then so it is going to give you same the carbon center radical of same stability, because it is symmetrically substituted. Either we cleave this, we get a radical here, or cleave this, so it is we can cleave any of the alpha bond, and then this will different pathway open for this is decarbonylation to give a this is one of the product which is formed through the exclusion of carbon CO carbon monoxide, and then corresponding aldehydes will be as so. This is going to get an abstract in hydrogen from here to give an aldehyde. Double bond. This is enaldehyde. It is also possible that this may abstract an hydrogen. This radical may abstract an hydrogen radical here. This will form a double bond this side or as well as this side. And then if we get another aldehyde, could be enaldehyde H. This is another aldehyde which is possible in this particular case. So it's also possible that the after decarbonylation, the intermediate which is formed is this one. This may also lead to, of course, combination is radical coupling is going to give this one, and also is also possible that this may abstract an hydrogen atoms to give a product like this H. So so these are possible photoproducts which is formed in the case of cyclic or alicyclic ketone. Coming to more examples, if we have a cyclic bicyclic system like this, have a system like this, has two methyl groups. So this is in the presence of light, is also a alicyclic ketone. Of course, the two cycle system is 6 and 5, and then this will undergo type 1 reaction, alpha bond cleavage, is going to be a preferential alpha bond cleavage. Alpha bond, because this is alpha carbon, this is alpha carbon. This alpha carbon cleavage is going to be preferential because going to generate a tertiary radical. So, and this will not take place because it's going to give you a primary radical. There are two hydrogens here. So preferential alpha bond cleavage is going to give a this is the first step in the generation of a carbon centered radical, and then this will lead to 1, 2, 3, 4. Maybe don't know how feasible it is, but on paper minus decarbonylation to give a this one, and this will combine, of course. May give a 4-membered ring. I don't know how stable this is will form or, but aldehyde is going to be really an important reaction taking place in this particular case. This will abstract a hydrogen, the aldehyde derivative to give the, say for example, the hydrogen from here to give a and this one, and the exocyclic double bond is a methyl group here. This is a, and then it's also possible that this radical may abstract in hydrogen atom to give a corresponding ketene, as we have already seen in the earlier example. This is H coming from here. This is ketene. This is another one, methyl group. So this hydrogen abstract from here the ketene. This is a ketene intermediate, and this ketone intermediate may give an ester, or it can give when it is in the presence of alcohol, it gives in the presence of water, it gives an acid. So the corresponding ester is going to be look like this. This is a methyl group. This is abstracted hydrogen. This is another methyl group, C double bond OOR. This is the corresponding ester which is formed. This is, of course, there are two hydrogens is going to come here, and then the corresponding acid is going to be same as this, except that instead of Ru we have a H. So this is a methyl group. This is the H abstraction. 1, 2. This is O, and this is OH. This is an acid. This is, and of course, this is a methyl group. So these are possible photoproducts in the case of this particular bicyclic ketone in the presence of light may undergo type 1 reaction involving preferential alpha bond cleavage, giving rise to acyl radical and more stable carbon centered radical. Different pathways open for this is decarbonylation to give a diradical radical, which may combine to give a carbocyclic system, but and the other pathways are abstraction of an hydrogen atom corresponding by corresponding acyl radical from from nearby methyl group to give an enaldehyde, and then also possible that other carbon may abstract a hydrogen atom to give a ketene derivative, enaldehyde. This is a carbocyclic system, and so on. So ester and acid, these are possible products which may end up with the system. Looking back a few more examples, let us see here. If we have a system like this, and again a bicyclic system, this is a 2-methyl group and the double bond. So this is a bicyclic ketone in the presence of light may also undergo type 1 reaction. Type 1 reaction is it alpha bond cleavage. So here again both the alpha carbons are symmetrically substituted, so we can end up with the cleavage of this bond or this bond. We get the similar stability carbon-centered radical. So it gives a radical like this, to give a radical, a sil radical like this, and now this will undergo minus CO to give this this one, and then of course minus CO, and then this will combine. So one of the most probable product after decarbonylation is going to be this one. This is a most probable product which is quite possible in this particular case to give this radical. And now it is also possible that this radical this may abstract an hydrogen atom from this. So if you write like this, if you write this like this, so this radical can abstract an hydrogen atom from this one, then this will is going to form a product like this. This one, the methyl group is a H here, this is a. So these are few possible products which are possible in this particular case. The decarbonylation followed by a preferential preferential alpha bond cleavage, decarbonylation, and then the carbon central radical will once again, because there is a adjacent double bond, it will lead to diene like this, or it will also possible to give you diene like this in this particular case.